Hi buddies, this is my introduction class for inorganic chemistry. So look at this board. We are seeing various topics. So that is in our syllabus, chemical periodicity. That is first one is atomic radius and ionic radius, and second one is covalent radius, third van der Waals radius, fourth one is crystal or metallic radius, fifth one is isoelectronic species, and sixth ionization potential or energy, seventh electron affinity or electron gain enthalpy, electronegativity, Slater rules, and tenth one is radius ratio. These are all important topics from chemical periodicity. These topics one by one we should discuss detail. So that is the definitions about chemical periodicity. So that is similar properties of elements arranged in order of their increasing atomic number. So what says this one? It's So that is similar properties of elements arranged in order of their increasing atomic number. So that is the previously, I'm not talking about applying to Mendeleev period. The definitions it is based on mass number, but I'm not going to detail about that one. So that is similar properties. This is most important. So it is ranged in a particular order that is called atomic number. So that is periodically ranged. So that is a specific order that is called a periodicity. So example, we should discuss. In periodic table, you know that is first one is hydrogen, and atomic number 2, that is helium, and third one is lithium, and the fourth one is beryllium, and boron, carbon, nitrogen, oxygen, fluorine, and neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So going these elements, this one is hydrogen, atomic number 1 and 2 and 3, 4, 5, 6, 7, 8, 9, 10. So that is, this is increasing order. So that is atomic number hydrogen 1 and helium 2, and after while going to range, which is like this, after neon, and then it is going to same properties like lithium. So sodium and its metallic properties like that one. This is atomic number is 11, and after going to 19, it is potassium. So these properties are same. These chemical properties are shows similar. So this is called chemical periodicity. Atomic radius. This is an atom. This is center part of nucleus. So this is center part of nucleus. So these distance in between the radius of this particular atom, that is called atomic radius. This atomic radius depends on two factors. That is, first one is we have to know about this most important van der Waals radius. So that is van der Waals radius means atomic means that atoms it doesn't react. So there is element nature. So this element nature of solid. So that is these two solids in between the minimum distance. So that is this one and this one is solid, and these are all solid. So in between, off of the distance, that is called atomic radius. Simply called van der Waals radius also. Here we can say van der Waals distance. Second one is, this is for element nature of solid, but if we go into molecules we can take, that is covalent bond. So what do you meaning of covalent bond? If equal sharing of electrons, that is called covalent bond. So this is two atoms, for example chlorine. So that's molecules is not like that, I'm sorry, that molecules are closely, this is Cl2. So that is half of this bond length. This is bond length of an atom. So that is internuclear distance between two covalent molecules. That is called bond length. Half of the covalent bond is called atomic radius. Here, covalent radius. So half of the bond distance or covalent bond distance is called covalent radius. That is equal to atomic radius. So that is this atomic radius. This rules only applicable for both of atoms. Atom A and atom B should be same. So chlorine and hydrogen gas, oxygen gas, these are applicable for this covalent radius and atomic radius rules because of these are homogeneous atoms. Covalent radius, if two atoms are different, so here involve another important factor that is called electronegativity. So this atom A and this atom B, these are all different. So here involve electronegativity concept. So one atom is dominates. So this, which is highest electronegativity, that is dominates, that is lowest electronegativity of the atom. So this is lowest electronegativity, this is highest electronegativity, which is capable to attract electron cloud from atom A. So its size is increases and size is decreases. So here we cannot say the half of the covalent bond. We cannot say like this because of this atomic radius is totally different. Atom two different, so we can use that is this formula. So half of the distance for homogeneous, but here cannot say half of the distance. So that is we are calculate the radius of atom A and the radius of atom B, and 0.09 and XA and minus XB. So that is here XA is, if you consider XA is higher electronegativity, XB is lowest electronegativity. So that is we have to subtract highest from lowest, so this shows negative value, and after we can calculate its distance. So these rules are this formula derived by this relationship derived by Schumacher and Stevenson. Ionic radius, that is this ionic radius, I mean ionic compounds are made up of positive and negative ions. So that is this distance. So the radius of a cation is called the radius of cation. This is for positive charge. This is radius of anion. This is called, these are all called ionic radius. This ionic radius, that is for cation is less than anion because of size of anion is higher. It is simple concept, but it has some exceptions we cannot discuss now. And this ionic radius is ionic radius is inversely proportional to atomic radius. ionic radius is inversely proportional to Z effective. Z effective nuclear charge. Z equal to Z effective equal to Z minus and yes. Z is effective nuclear charge and Z is Z effect. This Z is called atomic number. S is shielding constant. Effective nuclear charge. So, and details we have to discuss for the topic. So you know that is radius ratio rule. We can discuss ionic radius. Isoelectronic species means two species which has two species have similar number of electrons. The species may ion or atom. So these two ions or atoms which has similar number of electrons. So this is called isoelectronic species. Isoelectronic species means that is ions or atoms both have same number of electrons. For example, sodium and magnesium, sodium plus and magnesium 2 plus and neon. These three species has same number of electrons. So this is number of electrons here, neon 10 and magnesium also 10 and sodium 10. So this is called isoelectronic species. So size of atom and ions. So while going to the formation of sodium and sodium ion. So that is sodium loses its formation of sodium cation. So that is by losing formation of positive charge, its atomic radius is decreases. So atomic radius is increases with atomic radius is decreases with increasing oxidation number. The definition about ionization energy. The energy required to remove an electron from gaseous state. Ionization energy, the energy required to remove of an electron from a gaseous atom or ions. So this is called ionization energy. The unit of ionization energy is kilojoule per mole. So that is the energy required. It is also sometimes a positive charge. Positive or metal means that is so ionization energy kilojoules per mole, it is positive because of energy required. And here in periodic table, left to right, ionization energies increases. So sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So here this is ionization energy is lower than argon. This period argon has highest sodium, magnesium, aluminium, silicon, highest ionization energy. What are the factors affecting ionization energy? This first one is nuclear charge, atomic size or radius, penetration effect of the electrons, and shielding or screening effect, and final electronic configuration. So nuclear charge. So that is nuclear charge. Nuclear charge increases, ionization energy increases. From the period left to right, what happened? That is while increasing atomic number, what happened? Its effective charge also increases, and left to right, its size also decreases. So ionization energy increases. Atomic size and radius. So atomic size and radius, effective nuclear charge increases, so size of an atom decreases. Radius is decreases, so ionization energy increases. Penetration effect of the electron. So that is which is depends upon the shape of the orbitals. So penetration effect S, P, D, F. S is spherical, and this is dumbbell, this is double dumbbell, and F orbitals is various lobes. So that is here S, which has higher penetrating effect because of in 360 almost space is covered by s orbitals, so it doesn't allow to and its penultimate orbitals. But if you go into p orbitals, which is penetration, penetration means nucleus which can dominate the valence electrons, so this is called penetration effect. So if electrons are filled up in p orbitals, so which is easily influenced by nucleus. So that is the order of penetration effect. S is less than P and D and F. So that is if electrons are filled up in s orbitals, which has less penetrating effect and comparatively this order, and f orbitals which has highest penetration effect. Penetration effect of the electrons. Actually, penetration effect of the electron is not like this order. Penetration effect of the particular orbital like this, because of s orbital which has more penetrate with nucleus, and P, D, F. So the penetration effect of the electrons. So that is s orbital is spherical, and this is dumbbell, this is double dumbbell, and this one is various lobes. So this is, so in this space what happened, it's the probability of the finding the electron is spherical, here dumbbell, double dumbbell like this. So that is the domination of nucleus increases in p orbitals and d, f likewise. But s orbitals not like that because of totally shielded. So s orbital in the particular energy level which has more penetrating effect, so shielding is more. So this is shielding or screening effect also more, same order. So s orbital and P and D and F. So s orbital more shielding than P, P is more shielding than D, D more shielding than F orbital. And electronic configuration. So electronic configuration, it is also, so that is shielding or penetration effect is increases, size of an atom also decreases. So penetration of electron is increases, shielding effect also increases, and the size of an atom is decreases. So ionization energy is increases. So next one is electronic configuration. So electronic configurations, if an orbital, for example d orbitals, if fully filled or fully filled configuration which has more penetrating effect, so that is spherically it is how can I say, off filled or off filled or completely filled orbitals which has totally covered the particular atom and its size is decreases due to the influence of shielding effect. I mean off filled or fully filled configurations, so that shielding of electron is increases and ionization energy is increases, but otherwise it is depends on effective nuclear charge. So nuclear charge increases, ionization energy also increases. Atomic size increases, ionization energy decreases. And the penetration effect. Penetration effect is increases. What happens? Size is decreases, so ionization energy is increases. Shielding effect increases and the ionization energy also increases. So the penultimate, I mean valence shell, so if it is Ns and Np, so that is if a s orbital has more penetrating power, so it doesn't allow to dominate the p orbitals, the electrons in the p orbitals. So nucleus, it doesn't nucleus cannot possible to dominate because of its penetrating effect is more. So that is shielding effect also increases, penetrating effect, ionization energy decreases. Next one is electronic configuration. Off filled or completely filled orbitals which has more penetrating power, so size is decreases, ionization energy is increases. Generally, so in period, ionization energy is increases, but it doesn't follow same rules, which has some exception due to electronic configuration. So off filled or completely filled orbitals which has highest stable and which has highest ionization energy. So sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So sodium which has 3s1 and 3s2 in valence shell. 3s2, 3p, 3p1, 3p2, 3p4, 3p5, 3p6, 1, 2, 3, 4 and 5. So here sodium which is 3s1, 3s2 and aluminum is 3s2, 3p1, 2, 3, 4, 5, 6. So we have to find out the ionization energy. Here the sodium is least ionization energy, because of which it contains only 1 electrons, we can remove easy. But magnesium is higher. But next one is aluminum should be higher electronic configuration. Aluminum would be a higher electronic configuration, but actually magnesium is higher ionization energy. Why? Sodium order we should atomic number increases, ionization energy increases, but it doesn't follow. Sodium and magnesium order would be sodium and magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, but not like this. Why means that is aluminum which has 3p1. So this is if you loses 1 electrons, which is going to magnesium like stable electronic configuration. So its ionization energy is less than magnesium. But if you go into phosphorus, sulfur, so phosphorus which has half-filled electronic configuration, 3p orbitals, half-filled electronic configurations, it is difficult to remove. But if you go into sulfur, so it is more than half-filled, 1 electron. So we can remove 1 electron which is going to half-filled electronic configuration like phosphorus, so its ionization energy is less than phosphorus. And argon is stablest element, it is not possible to remove, so that is this order like this. So the highest ionization energy is argon, and lowest is sodium. Even though sodium is lowest, but aluminium and magnesium and sulfur and phosphorus, which has anomalous properties. It doesn't follow the general definitions of ionization energy. First ionization energy is less than second ionization energy. Y means effective nuclear charge is increases, so it is size is decreases. So while size is decreases, ionization energy is increases. And third ionization energy is more than first and second. The energy raised from. So for example, X, a particular element which is gaseous state. So while addition of an electron to this gaseous atom, and which is going to negative charge, and some amount of energy is released. So this energy is called electron gain enthalpy. Definition of electron gain enthalpy: the amount of energy released when a neutral gaseous atom accepts an electron to form gaseous anion. So that is, after formation of gaseous anion, the amount of energy is released. The amount of energy released when a neutral gaseous atom accepts an electron to form gaseous anion. So after formation of gaseous anion, so that amount of, so electron gain enthalpy negative because of energy is released. Electron gain enthalpy is negative, but electron affinity is positive. So electron affinity is higher means it should be positive. The order of electron gain enthalpy, that is chlorine and fluorine and bromine and iodine. So why in periodic table fluorine has lowest electron gain enthalpy comparatively chlorine atom? What's the reason? Because of fluorine, which has if you get one electrons, its size is increases. So while size is increases, electronic repulsion is more. So its stability is very less. But if you go into chlorine, which has compress, because of it is which is 3s2, 3p, 6 and 3d orbitals. So that's may, which can how can I say, which can if you accept one electrons, so which can possible to more space because of the presence of 3d orbitals. So it's which has highest electron gain enthalpy in the periodic table. Hi buddies, so that is this is enough. So today we discussed about the important topics of chemical periodicity. That is, first one is periodicity, atomic radius, ionic radius, and ionization energy, electron gain enthalpy, and electron affinity. These topics we discussed. Next class we should discuss electronegativity and the radius ratio rules, and electronegativity, how to measure, and Slater rules. These topics we should discuss. Thank you.